Partial fraction decomposition, part 1, linear factors. Welcome to Mark's Math Methods. Here is the goal of partial fraction decomposition in simple terms. We want to convert 9/10 into the sum of two fractions. We could have 9/10 is a half plus 2/5, or maybe 9/10 is 1/10 plus 4/5, or 9/10 could equal 7/10 plus 1/5. Which one? The work becomes, what denominators do I use? And then, how do I find the numerators? Let us walk through a problem. Example 1. Convert 3x minus 7 over x squared minus 2x minus 15 into the sum of some fractions. First, we have to factor the denominator. So we need to factor x squared minus 2x minus 15. And that is x minus 5 and x plus 3. So we're going to use those factors as the denominators in our fractions. So one fraction will be something over x minus 5, and the other fraction will be something over x plus 3. Let's put in some placeholders for those unknown numerators. So I'm going to put an a over the x minus 5 and a b over the x plus 3. Now we need to find the values of those placeholders. So we take our equivalents here. 3x minus 7 over x minus 5 times x plus 3 equals a over x minus 5 plus b over x plus 3. We're going to find the a and b, we need to first clear the fractions by multiplying the whole equation by the least common denominator. So when I distribute onto the left side, the x minus 5, x plus 3 cancel, so I just have 3x minus 7. So now on the right side, into the first fraction, the x minus 5's cancel, so I have a times x plus 3. And into the second fraction, the x plus 3's cancel, so I end up with b times x minus 5. Now the magic. Let x equal -3. Notice that the x plus 3 becomes 0, which means the a is no longer involved. So when we plug -3 in for the x on the left side, we get 3 times -3 minus 7. And on the right side, we get b times -3 minus 5, which gives us -9 minus 7 on the left, and on the right, b times -8. -16 equals -8b. Divide both sides by the -8. So now we know b is 2. And we do it again for the other. We'll let x equal 5. We plug in a 5. Oh, the x minus 5 turns into 0. So the b is no longer a factor. So when we plug 5 in for the x's that are left, we get 3 times 5 minus 7 on the left, and on the right, a times 5 plus 3. So 15 minus 7 is 8 times a, or 8 equals 8a, or a is 1. So 3x minus 7 over x squared minus 2x minus 15 written as two fractions is 1 over x minus 5 plus 2 over x plus 3. But why are we doing this? How do you feel about integrating this? Ugh. Does this look easier? Oh yeah, that looks much easier. So we end up with the natural log of the absolute value of x minus 5 for the first integral plus 2 times the natural log of the absolute value of x plus 3 plus c. This is why we do partial fraction decomposition. Taking a complex fractional integration and making it into smaller, simpler ones. Let us walk through another problem. Example 2. Convert negative 29x minus 56 over 2x cubed plus x squared minus 2x into the sum of some fractions. So just like before, we need to factor the denominator. We have a common factor of x, and then we have a quadratic we can factor further. So we've got negative 29x minus 56 over x times 2x minus 7 times x plus 4. Now we use those factors as the denominators. So now we have three fractions. Let's put in our placeholders. So we have a over x plus b over 2x minus 7 plus c over x plus 4. Now we need to find the values of those. So now we need to clear the fractions. So we multiply through by the common denominator. On the left-hand side, everything disappears, so we're left with negative 29x minus 56. Times on the right side times the first fraction, the x's disappear. So it's a times 2x minus 7 times x plus 4. The 2x minus 7's disappear, so it's b times x plus 4. And at the end, the x plus 4's cancel, so it's c times x times 2x minus 7. And now the magic, right? Let's let x equal 7 halves. That's going to eliminate this one and the one at the end. So all we're left with is b. Plug in the 7 halves for all the x's. So negative 29 times 7 halves minus 56 equals b times 7 halves plus 4. So negative 203 over 2 minus 56 equals b times 7 halves times 15 halves. Negative 315 over 2 equals 105 over 4 times b. Now we'll multiply by 4 over 105, and we get b is negative 6. Let's set x equal negative 4. That will eliminate the first two, so all we left us with is c. Plug in negative 4 for all the x's. Negative 29 times negative 4 minus 56 equals c times negative 4 times 2 times negative 4 minus the 7. So 116 minus 56 on the left. C times negative 4 times negative 15 on the right. So 60 equals 60c. So obviously c is 1. And then let's set x equals 0. That will eliminate the b and the c, so all we have left is the a. Plugging in the 0, So we get negative 0 minus 56 on the left, a times negative 7 times 4. So negative 56 is negative 28a. So a is 2. Now the order in which you do these, 0, negative 4, 7, doesn't matter, your choice. Okay, doesn't matter. So now we know what a, b, and c are. So now we have negative 29x minus 56 over x times 2x minus 7 plus 4 is equal to 2 over x plus x minus 6, 2x minus 7 plus 1 over x plus 4. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.